So essentially, the general name for malware is an artifact. It's something that has been captured that needs analysis. And so we're going to talk about all sorts of these sorts of things, give you an overview. With forensics, we talked about a process. With malware, guess what? We're going to talk about a process. Same idea. So an artifact is something that is left by an intruder, whatever that turns out to mean. And you should assume that they're malicious until proven otherwise. They might be benign, but they are assumed to be malicious. Artifact can be any of these things. Tools used by intruders, tools installed by intruders on hosts, malicious program, evidence like documentation, like a README file, this is what this program does, and output from intruder tools. And unfortunately, we won't have the time today. I can tell you that we won't. But if you take the Advanced Incident Handling class, there's a whole afternoon devoted to a very large artifact analysis of a Linux-based artifact that has all of these sorts of things. Tools that were installed, README files, et cetera, are part of this. So artifact analysis is you take this unknown thing and you try to figure it out. This is essentially what we're talking about. What does it do? And in the context of doing an investigation, you want to know what this unknown thing does so that the investigation continues. You're doing your analysis, you find a piece of malware, you want to know what it was doing. Is it beaconing out? Is it sending stuff? Because you want to continue finding the next thing in the trail as to what was actually going on. You may find that and analyzing it leads you to understand what vulnerability was leveraged, and from an incident response point of view, you can tell your people they have a hole that they need to close, and there's a patch, and there's an active vulnerability they need to deal with, et cetera, et cetera. Determine what artifacts might have been used, given the footprint or remnant left behind. In other words, here's an artifact that changed 17 files. That means your host was compromised with this, they did this, and now they're exfiltrating PII. That's really the information you want when all is said and done. So artifact analysis, you actually find artifacts in the process of doing incident response or incident handling and forensics. And then this is another branch that digs deeper into understanding what that artifact does. In the context of incident handling, not all teams do forensics. In the context of incident handling, not all teams do artifact analysis. And so that becomes, you might not find everybody doing everything. So the idea is, what does it do? And do I know anything about it? Have I seen it before? And can I leverage what I previously know, or has somebody seen it before? And I can take advantage of what they've done. I don't have to do it myself, and I can tell my people, and the investigation continue. Sometimes it's possible to see an artifact in operation, to define its signature. Sometimes you can develop solutions for workarounds by understanding what it does. So before we dig deeply into artifacts, you're going to do some artifact analysis. This is an artifact. Okay? It's one for the first row. And if you happen to know what it is, keep it to yourself for now. But the idea here is, this is the thing. We're going to call it an artifact. How would you analyze it? And yes, it came from Lowe's. So what would you do? This is an unknown thing that you perhaps have never seen before, and you need to analyze it because you need to understand what it is, how it works, where it may go, etc., etc. So I'd be interested, for those of you who've seen it, what would you analyze it? How would you deal with it?
Gaskets. Try to take it apart.
Try to take it apart, okay.
Go to Lowe's.
Say again? Go to Lowe's and find something. Well, that's basically, you're looking for something that looks just like it. That's basically a signature analysis. So yeah, that's a reasonable perspective. See how it moves, so try to operate it.
See the nature of it.
Okay, so you're looking for so you're looking for clues in it that meant like a part number or something that you could do.
Like
Okay.
the line.
Yeah,
the green discoloration. It's also on the copper part of it.
I think it's like a refrigerator or something like one of the valves for water's coming in and going out.
Okay.
Yeah, cold water flows. Colder water, or some sort of
What's that?
describe.
There is something for water. It's cold water that flows forward.
It's the knob that goes from cold to hot.
Oh, okay.
This is some type of juncture right here. That,
So since it's from Lowe's, it probably comes from a house. That's the easy part. So where within the house? Oh, there we go. A little analysis here. My point is malware analysis. My point is to suggest that you already know how to do an amount of malware analysis. Because malware analysis is nothing more than looking at something and trying to determine something about it, which is precisely what you're doing here. You looked at it, you saw rubber circle things there around the bottom, which probably gives you a clue that it's a wet environment. So this is, as you said, this is a plumbing part. It probably is used in some kind of a water situation. And that's exactly correct. Anybody know what it is?
It could be refrigerant line where the water comes in and then one goes to ice maker, one goes to water.
It could. It's not, but it could.
I've replaced one that looks just like that.
oh, there's the sides of a water faucet, so you switch between cold and hot.
And where would you likely find that? Kitchen sink would be one.
Or bathtub.
These come from my shower at home. It's you have a shower that's got the one handle, and you rotate between hot and cold, and you can go so far, which is with the white plastic piece that restricts how far you can go, so you don't scald yourself in the.
I want to go to your house. And I was like, how many showers do you have?
In our house, we happen to have 4.
Oh, okay.
But that's what it's for. You can control, you don't scald yourself, you don't freeze yourself, what have you. And so basically what you just did was you evaluated, you looked at it, some of you shook it, somebody took it apart. You could have x-rayed it to see what's inside. You could have cut it in two with a saw and saw what was inside. I like the idea about going to Lowe's and finding something that looks like it. That's like a signature analysis. Do I know anything about this?
The wording was in English and not in another language. It was encrypted or something.
Right. So part number lookup. All of those are valid ideas for doing malware analysis, and that was my point in doing that. Okay. So that's what the goal is, and you just went through that. So now we'll talk some more about if the malware were actually a hunk of bits purporting to be a program that does something. So here's who does malware analysis. I'm actually going to skip through some of these, otherwise we'll never get done. A lot of people can do malware analysis. You can actually do it at home too. The key to malware analysis and doing it is these have to be done in the right place, because this is potentially bad code that can wreak havoc in the environment. And so you may want to do that in an environment where wreaking havoc is okay. And let me suggest that the office on your office network is probably not a good choice. Okay? That's the idea. So you may decide what to analyze. Somebody has to decide this is the piece of malware that needs to analyze because it's related to a case that is multi-millions of dollars, so we need to know where the information has been exfiltrated, what have you. Artifacts come from everywhere. We typically find them in systems that have been made available to us that have been compromised, or for example. We also have a system, we have a mechanism where law enforcement can drop artifacts to us, a drop box. And they can be run through an automated system, and in 10 minutes you can do a top-level analysis and help law enforcement understand what's going on. So there's all sorts of ways to get a hold of these. And like harsh chemicals, you have to take care of them in a reasonable fashion lest they do their thing. You can, within a Windows world, you can add an extension onto them that has no meaning. So some of the, quote, automatic and helpful features under Windows are defeated. I don't think there's a .mal that's a real extension that has real meaning to an application, so that's a suggestion. So this is what we've been doing at CERT since 2000. In CERT, we created a team that was renamed to the Malicious Code Team. they have a huge catalog, and they do analysis of this catalog, differences between malware. You can take a piece of code and split it into individual parts and look and see if you've seen those individual parts elsewhere. Because a lot of time people who write malware will share the malware, and you wrote it and you fix it and you do something else to it. There's still commonality between the three variations, and that can be determined.
Just one question. Do people do analysis on code writing? For example, I write code a whole different way than
Yes.
he does. All my code kind of looks the same to
Yes. And the example that I use is the person who builds bombs. If you look at the bomb, you can determine that the bomb maker was left-handed based on how the wires were put together. So you can determine something about that. So people are, in fact, doing malware analysis to determine the similarity of the code. They can trace, this malware has this module from Fred, and we know it's Fred, and his module is used in all of these other derivative work. So yes, people are doing that, and we're one of them.